Okay, good morning, everyone. Hello. We made it. You all survived the party. That's great. I'm glad to have such a good crowd here. Let's get going. We got about 40 minutes and a lot of stuff to cover. So, that on. Okay. So I am Charles Nutter, Charlie to my friends. This is my first time to Budapest, and I'm having a wonderful time exploring and trying craft beer and seeing all the sights. I've done 3 EuRuKos. I have not done any of them since Amsterdam, so it's been several years. And before that, I did the one in Prague. So this is the only 3 EuRuKos. I'm really excited to be back. I work on JRuby. I'm a co-lead of the JRuby project at Red Hat. Very thankful for 5 years of sponsorship by Red Hat. They keep the project going and help us work within the community. So we're going to tell a little story today. So once upon a time, oops. Ooh, I don't know what that's doing. So, 24th of February, 1993. How many people know that Ruby is actually this old? Oh, 24 years. Okay, yes, it's been around for a while, right? Okay, I'm going to give up on that thing. So, our wonderful friend, the man who changed the world by creating Ruby, this is when it all began, 1993. And for many years, it was pretty much just well known in Japan. It was not internationally known. It continued to evolve and have new releases. But it was not really until about 2000 when these two fellows, Dave Thomas and Andy Hunt, the pragmatic programmers, released one of the first books in the United States for the Ruby programming language, the original Pickaxe book, the first edition. Around the same time, this gentleman, Jan Arne Petersen from the University of Bonn, also became interested in Ruby. And he went on to actually do about a year after the book came out, went on and did the first commit, the first version of JRuby. And this is where it all started. So how many people knew that JRuby actually was started in 2001? Much older than you'd expect, yes. This is surprising. Almost none of the original people are still on the project, and we've probably rewritten every single line of code in that intervening time. But JRuby's actually been around for quite a while. So what did we have in the beginning? JRuby started out as essentially just a Java implementation of the Ruby parser, so that it could be used for tooling, it could be used for code analysis, and so on. So initially, it was really just a parser. Thank you. Let me fix that. Okay. So originally it was just the parser and a few pieces of the little core classes. If you've ever worked with Ruby's parser at all, you'll understand that there are Ruby strings and Ruby arrays that actually are in the parse tree too. So you need some of those pieces. Very early beginnings of an interpreter for it, but it was primarily just the parser, language processing, and so on. About a year later, my good friend Tom Annabo, here's Tom doing one of his trademark Tom faces. We travel around the world and check in beers together, and I always try to make sure I have him in the background doing one of his sad fish faces. About a year later, Tom Annabo actually got his first patch into JRuby. So he's been around in the project even longer than I have. 2002, as we often do with open source projects, his first commit was just deleting a bunch of stuff. But it was a beginning. He got involved, he got started, he got interested in Ruby, wanted to make JRuby happen. So around this time, the interpreter is starting to fill out a lot more. We've got more of the core classes taking shape. And this structure of the project has largely stayed the same to this day. The main org JRuby package has all of the core classes, and then we've got compiler, interpreter, and so on packages underneath that. So, 2002 or so, this is the core team. Even folks like Chad Fowler in the early days making small contributions to the project. And it started getting going. This started actually working. So it's about two good years, 2 busy years of releases. The 02 to 03 lines during 2001. A little bit of a versioning change here. So it was based on Ruby 1.6. So for a while, they had 1.6 underscore the rest of the version. Throughout 2002, continuing to improve compatibility. Basic code is starting to run. Basic integration with Java code and Java libraries. And then it kind of went quiet. So for about 2 years, there were no releases. Code continued to get put into the project. There were small improvements, but not really any releases for a while. Meanwhile, Ruby itself was moving forward, and it jumped another major version to Ruby 1.8. And this would form the basis for the Ruby community, the Ruby world that we know now. The 1.8 series really started to take off. The Pickaxe book was getting picked up more and more conferences. And JRuby started to fall behind a little bit here. Just not enough folks working on it. Nobody was sponsored to do it. And implementing Ruby takes a lot of work. So 2004 was another big year for Ruby. I had the pleasure of going to RubyConf 2004 and managed to see such well-known Ruby figures like David Hansen present Rails for the very first time. I got to see Koichi present the YAR VM, which would become the basis of the Ruby we run today for the first time in the US anyway. Jim Weirich was there talking about this new project, Rake, he was working on, and Ruby Gems. And while we were there, they even got together and did hackfests on the earliest versions of Ruby Gems and Rake. It was a very exciting time. In comparison to the Ruby crowds we have today, there were a grand total of 65 people at RubyConf 2004. We all got to know each other, and it was a lot of fun. It was the fourth Ruby conference in the United States, but the first one that I actually got to go to. So at the time, I was a Java enterprise architect. It's exciting, isn't it? I reached the pinnacle of Java development as an enterprise architect. And the company I was working for was based in the Washington, D.C. area. So I traveled out there from my home. Turned out that there was going to be a RubyConf right about the same time I was in town. RubyConf 2004. So I paid my $50, and I went to the conference, not even really knowing what this language was. It was recommended to me by a friend. You should check out this Ruby language. It's kind of cool, kind of fun to play with. I knew nothing about it, but every talk, every slide, every code example I saw, I could read. I understood it immediately. And this had never happened to me. As a Java developer, I would go to Java talks as a Java architect, and I would not understand what I was looking at on the slides. So sight unseen, I was able to understand all of this code, and I was like, wow, this is amazing. But I'm a Java guy. I've got to find some way of using Ruby in my job as part of my Java platform. And so being from Minnesota, where half of the year we're under a layer of ice and snow, I thought I might look around, see if there's somebody's done a JRuby project. Maybe there's some sort of project that has a Ruby on the JVM. And well, it turned out there was such a project. My old friend Tom was the current maintainer and pretty much the only person working on it at the time. So I got involved. I started to make my own small contributions. Again, as we often do in open source, I just improved some build aspects of the project. And this thing started to actually work. It was a lot of fun. I was spending my weekends, my evenings on this, trying to get stuff going, trying to improve the performance, trying to improve compatibility. About a year later, in 2005, I gave my first ever presentation anywhere. At RubyConf 2005 in San Diego, I think it was. This is me doing the first JRuby talk anywhere. I believe the first JRuby talk anybody had ever done at that point. And I walked through why you would want to do this, and I wasn't quite booed off the stage, but there were a few interesting comments from folks. Why would you do such a horrible thing, combining these two, the beauty of Ruby and the horror of Java? This is, of course, when Ruby was largely made up of people who were former Java programmers. So this was like a post-traumatic stress for them, to have me come up on stage and say, I'm bringing Ruby to Java. You will never escape Java. Never. But it went well. The talk was actually well received by a number of folks, and we managed to continue working on. So we'll fast forward a bit here. It's been 11 years since I got involved in JRuby. 11 years since we were hired to work on JRuby by Sun Microsystems, one of the first companies that was willing to sponsor our project and help us make it go. We've had hundreds of contributors over the years. We still have dozens that come and go on a regular basis. Thousands of issues. We're on our second bug tracker now, having moved off of Jira to GitHub, and in both cases we have thousands of issues that we've worked on. Tens of thousands of commits. I think it was 43,000 commits to JRuby the last time I checked. And then, of course, a huge thank you to all the companies that have sponsored us: Red Hat, Engineered, Sun Microsystems. JRuby would not exist without this kind of sponsorship. So let's get into JRuby itself here. What is JRuby today? What do we have? Well, JRuby is Ruby. First and foremost, it's Ruby. We don't emphasize the fact that it's Java or on the JVM. If all you do is Ruby and all you want to see is Ruby code, that's all you need to worry about. We focus very heavily on compatibility. 98% of the core language specs pass. The features that we don't have implemented, you're not going to miss. How many people have used the flip-flop operator in Ruby? Yeah, like 5 people. If you really want it, patches accepted. But it's an unusual feature. We just haven't bothered to do it with our new interpreter. 94% of the core class specs. And the stuff that's missing here is often very platform-specific things. We can't fork the JVM, for example. So a whole bunch of those tests don't pass. Some of the other more unusual process management things, we've had to kind of choose what we implement to make it not too incompatible with the JVM. JRuby 9.1 is the current release line. So if you're going to grab JRuby, this is what you're going to get, and that's Ruby 2.3 compatible. How many folks have moved to Ruby 2.4? All right, so some folks are moving on. That's good. So we have Ruby 2.4 compatibility is pretty much done on master. Those of you who are using Ruby 2.4, very much encourage you to check out our nightly builds, see if things are working, see if there's missing features. But we've gone based on CRuby's tests to know whether we've got our features implemented properly, and with probably 99% of the tests written for Ruby 2.4 features pass now. So I think we're pretty good. We're putting some finishing touches on this, and hopefully we'll have that released around RubyConf time in about 2 months. So one tricky area for us has been native extensions, but the JRuby ecosystem has matured a great deal over the years. Almost all popular native libraries that see extensions for Ruby do have JRuby versions. There's JSON and Nokogiri and so on. They're all out there, and they have JRuby support. Many others, if there's a native extension, there's also often a pure Ruby version that works very well on JRuby. In fact, in some cases, JRuby can run the Ruby code for an extension just as fast as MRI can run the C code. So usually it's not a problem if we just use the Ruby version of it. We also have been supporting the FFI library, foreign function interface. We maintain the FFI for both JRuby and CRuby, which allows you to just write Ruby code, load up a C library, and start calling functions on it. No extension required other than FFI itself. And then, of course, there's an entire library of Java classes and Java libraries that are out there, and Scala and Clojure and Kotlin and whatever else, all that's accessible through JRuby. And I'll show some examples of that later. So, of course, Rails is still the big hitter as far as Ruby community goes. Rails 5 works pretty much, it pretty much works today on JRuby. The main issue is that there was a large re-architecting of how Active Record worked internally. So we have kind of lagged behind on Active Record support. We're currently working on some new adapters that will finally get us full-on Rails support. These new adapters are going to be much cleaner as well. So about 75% of the code that's in the SQLite version, which is mostly done now, is just the code from Rails. We've really reduced the footprint of what we have for custom code for JRuby, and that is also because of the re-architecting. They've done a better design of Active Record that separates the database driver from the object relational mapping stuff. We've also tried to support previous versions of Rails with the same driver. So you look through the code of the old Active Record JDBC drivers, and it would be, if it's Rails 3, do this. If it's Rails 3.1, do this. If it's Rails 4, do this. That's all gone, so we don't have to maintain that kind of stuff anymore. It should be much quicker and easier for us to keep up. And we are going to work with Rails to try and get our drivers actually as part of Rails proper. Then we can maintain it all in the same place. We'll know if things fall behind, and we can keep up our compatibility level. But the good news is that with the extension, with the new version of our Active Record adapter, we're in the 99th percentile of supporting Rails tests. This is by far the best we've ever been. So if you're doing Rails, we'll get these adapters released in the next month or two. Should be good for your applications, should work fine. So then if you've got an application you've built in JRuby, how do you deploy it? I mean, I assume you have to use a Java application server, right? Well, no. Again, we are a Ruby first, and we've always focused on making the Ruby way of doing things work properly. So servers like Puma we recommend. They work just as well on JRuby, and much better in some cases, in fact. The typical ways of deploying Ruby applications work. We do have other Java-style ways of deploying stuff. The Torquebox server essentially wraps a Java enterprise set of services with very nice Ruby interfaces and a nice way of bundling it all together, configuring it all in Ruby. You never have to see the Java parts. Warbler lets you take an entire Rails application with JRuby and all of its dependencies, put it in one file, and just run it. You can throw it on a server, java-jar this file, you've got an application going. Simplest way of packaging up an application for Ruby, by far. And then, of course, integration with Maven, integration with Gradle, all of the other Java tools that are out there. So if you're familiar with the Java side of that ecosystem, JRuby fits pretty well into it. If you're more interested in more, strongly recommend picking up this book. Joe did a great job of covering lots of different ways of deploying applications, from typical Capistrano sort of deploys, to WAR files, to Torquebox, and Heroku, and everything else. So a good one to check it out. So now the other half of JRuby is that we are a JVM language. And so we get the advantage of being on the Java platform. We get better garbage collection. We get native JIT. We get parallel threads, and all of the libraries, of course, that are available. So we'll talk through some of this and show you what this looks like. So first off, the tooling, the VM and the tools that come with it. I mentioned that there's a wide range of garbage collectors. On the JVM, there are collectors that will run in parallel with your application. You don't see pauses. They will use all the cores in the system to run as fast as possible. Generally, garbage collection is not going to be a problem for you on JRuby, if you've ever had issues on CRuby at all. Of course, lots of tools for monitoring the system, monitoring the JIT, monitoring the GC, so you know whether things are running properly. You can diagnose problems, get to the root of it. And you can do all of this remotely, too. You can connect up to an existing application, even in production, see what's happening, see what the code's doing, see how the GC's running, and whether there's any problems. One of my favorites is a free tool that comes with OpenJDK, the standard JDK that most folks use, called Visual VM. You basically can connect up to your running application, and you can monitor what all the threads are doing, how the garbage collector is working, dump the heap, and so you can see what sort of objects are there, look for memory leaks, and so on. And like I say, this is free. It comes with OpenJDK. So here are two different views of Visual VM. On the left here, we have just a simple monitor of CPU usage, generally what the heap is looking like, the orange line on the heap side there being the total size, the blue line there is how much of it's being used at any given time, how many threads you have running. On the right is a plugin for it called Visual GC. And this is a live view of what the garbage collector is doing in the application. You can see the generations will fill up, the garbage goes away, some of it might get promoted to older generations, but every step of the way you can monitor what's happening in the garbage collector and see if you've got leaks, see if you're spending too much time processing garbage, throwing objects away, but really nice visibility into the system. And like I say, you could connect this up to a production application anytime you want and see what's happening. It also has tools for profiling your application. Now, these are kind of slightly mangled names for the Java VM so that we can put the code into Java, but you can generally see it's Ruby bench, it's a bench red-black script, and then we've got the methods, successor, reverse in-order walk, and so on. So a little bit mangled, but it's still pretty readable. And then you can see how much time is actually being spent in each of these methods. And the JVM does a great job of monitoring this. It can sample and see what code's running at any given time, or it can do exact timings and show you how much work is being spent in each method. All right. So we've got our application. We're monitoring it. We want to know how to optimize this thing. We're working very hard to make JRuby run fast, make Ruby code run as fast as possible on JRuby. So what can we do here? Well, so we have our own optimizing interpreter, first of all. It will run your code for a while, see what's happening, see what types of objects you're using, see what methods you're calling, and then we can do a little bit more intelligent optimization after that. Then eventually, if code turns out to be hot and it looks like you're using it a lot, we can turn it into JVM bytecode. And then the JVM will go on and take that and eventually turn it into native code. JRuby was really the first native JIT for Ruby. I think we finished the actual JIT in 2008 or so. So almost 10 years that we've had a native JIT for Ruby in the JRuby project. More recently, in Java 7, a feature called Invoke Dynamic was added. This allows us to explain to the JVM how dynamic calls work, and then it will optimize them just like they were regular static Java calls. This has helped improve performance significantly on a number of benchmarks. I'll show some of that in a bit. Now, we are going beyond this at that point. We are starting to look more at optimizing the Ruby code before we turn it into JVM bytecode, doing some of our own inlining, doing some specialization. If we see it's a numeric algorithm, let's turn it into just raw Java primitive longs or primitive doubles to make it run faster. We're also looking at a new JIT called Graal that can plug into OpenJDK. But the interesting thing with Graal is that it's a JIT for Java that's written entirely in Java. So we can tweak it. We can say, optimize this Ruby code a little bit differently. Optimize this part more, use the numbers, optimize the numeric aspect of it more. So we can tell the JVM how to optimize Ruby, and this is showing some great results. Let's take a look. So first of all, we've got just a benchmark that's essentially like a array each with blocks and loops and whatnot. We want to be able to optimize through all that. So the numbers here are basically how much faster JRuby is than CRuby MRI 2.4. So without doing any invoke dynamic tricks, just our basic JIT, about 1.25 times. So kind of on par with CRuby. Not terrible, but we'd like to see a little bit more performance here. If we add invoke dynamic, it helps a little bit in this case, but there's still some issues. The JVM doesn't optimize blocks very well. And it's even a problem for Java 8 lambdas, the same sort of issues that they're having, we're seeing here. Now it starts to get interesting. If we start to do our own inlining, we can take that loop and we can take that block, turn it all into one piece of code, and save all of the overhead of doing that block dispatch and all the extra bits that the JVM can't optimize. Now it's starting to look a lot better. Add invoke dynamic back in, even better here. Eight times what we were looking at in CRuby 2.4. And then Graal also helps a little bit on this one, too. Optimize things a bit. So where Graal really shines, though, is in our numeric algorithms. JRuby, being on the JVM, we need to use objects most of the time for all of our numbers. So fixed nums are objects. Every time you're doing math, we have to create a new fixed num. Floating point is all objects as well. The nice thing about Graal, however, is that it can take some of this and optimize those objects away if we tell it how. So JRuby with just the JIT and invoke dynamic, this is a Mandelbrot generator, still pretty good, almost 3 times faster than Ruby 2.4. But if we pull Graal in and tell it how to optimize numbers, how to get rid of all that object overhead, then things get much more interesting. And we're going to start seeing more and more of these gains across Ruby projects as we play with Graal, as we work on our own optimizing compiler. So we're going to get some great results out of this. All right, so one of the other big areas that JRuby has an advantage is in concurrency and parallelism. So what is concurrency and parallelism? These terms kind of get tossed around. It's a little confusing. So parallelism is what happens on the hardware. You've got 2 pieces of code that are executing at exactly the same moment. So multiple cores doing their own thing, that's parallelism. Concurrency is more abstract. It's at a software API level. It's the idea that 2 different tasks will progress at the same time. They may not run at exactly the same moment, but bit by bit, those 2 threads will actually get work done. And so you can have concurrency without parallelism. That's what we have in CRuby. You can have multiple threads, and they will make progress over time, but at any given moment, only 1 core is going to be in use. You don't get to take advantage of all of those cores unless you spin off another process, at least 1 per core to use them all up. But in JRuby, you get both. We have all the same concurrency APIs that you have in CRuby, but you get parallel execution, and you can actually use all your cores with a single JRuby instance. When you're looking at some large Rails applications where you may have 10, 50, 100 instances in order to try to take advantage of the system, that can all just be 1 JRuby. And it'll saturate the system, use far less memory than all of those individual Rails instances, and you'll get the best use of the hardware. Now, some more fun areas where you can play with JRuby is being able to script Java libraries. You can call into any Java code, or as I mentioned, Scala, Clojure, and so on, just as if it was Ruby. You just pull the code, just say import this class, or call it directly, and all the rest is figured out for you. I'll get some examples here. Here is a little JIRB session. So we're creating a new frame using the Swing GUI library that comes with the JDK. Create a new frame, create a button and add it to the frame, set the size of this frame, and set it visible. And now we've got the user interface that easily. And now you'll notice that most of this looks like it could just be Ruby code. Set size here, set underscore size. Of course, on Java would be set capital S size. We turn all the Java naming into Ruby naming so that it looks more like regular Ruby code. Frame.visible equals true. Well, that's frame.setVisible in Java. But when we have simple setters and getters like that, we make them into attributes like Ruby would do. So you can write code against Java libraries, and no one would really ever know that you're calling into Java, and except if they look at the Java X Swing, that's about the only clue they'll have. The rest of it is pretty well hidden. Now, there are some newer libraries for doing graphical interface development. JavaFX has been pushed on the Java side by Oracle. This is a more declarative way. You create an interface using an interface builder tool, and then bind it to your application logic. Well, we have a wrapper for this called JRubyFX. And this is just a little bit of JRubyFX code where we're pulling in some FXML, the definition file for the user interface, binding it into standard Ruby instance variables, and then we're writing a GUI application for JavaFX entirely in Ruby at that point. A larger example of this is the Brakeman Pro, the commercial version of Brakeman for analyzing your code. This is all JRuby and JavaFX. And we've worked closely with them to make sure this runs well, make sure it looks good. So this is live code that's out there in a commercial project. And now this is all great that we have these tools and we can build GUIs, but maybe something a little bit more fun. So Tom worked on a project called Prugin, which is basically writing Ruby plugins for Minecraft. And here is a little bit of code that shows we're modifying how many chickens come out of an egg when you throw it. Normally it's 1 or 2, maybe 3, I think it was. Here we're saying let's do 120. And so very quickly, Tom managed to destroy his world here. He thought that he might be able to do the same thing for wolves, and the wolves would eat the chickens or something, but it didn't work out that way. He just had to throw that world away. There was too much noise. And of course, there's so much more that we can do here. All right, so what's next? Well, first of all, I wanted to point out that JRuby is not a new project, obviously. We've been around for a long time. There are hundreds of companies out there running JRuby. This is just a small sampling of some of the folks that are using JRuby for real applications, either commercial applications that they distribute and sell off to people, or services, Visa and BBC. For example, the BBC election results that you see, that's all JRuby in the back end, providing all of the election information for anything they're doing there. So this is very exciting. There's more and more companies out there. If you're using JRuby, I'd love to hear from you and talk about what you're using it for. So how do you get involved? How can you get into JRuby? Here we have, this is the JRuby site. You can just download the tarball. Unlike CRuby, there's really nothing to build. You unpack it, put it in your path, and go. It's ready to go. You can also just use one of your favorite Ruby installers, RVM or Ruby install or whatever. They all support JRuby. They know how our versioning works. So you should just be able to install JRuby and have it running. Really, the only prerequisite is go get OpenJDK and install it. It's available for every platform. There are Linux packages. As Linux packages tend to do, they lag behind. But they are still, within the last few months, I think they're keeping up pretty well. And if you're on Windows, how many people are doing any Ruby development on Windows? Yeah, it's kind of a no man's land for Ruby development, isn't it? Well, the good news here is that if you're on Windows, if you're having trouble, or if you have a client that expects you to deploy on Windows, JRuby works pretty much the same on Windows as it does on any Unix. We don't have most of the dependency issues. Most of our extensions are written in Java, so they'll work on Unix or Windows or any platform that you want, work pretty much the same. And we have an installer that will get it into the Windows way of doing things, and it looks good. And as I mentioned before, you can just unpack it and put it in path, and it'll work. So other things that we're hoping some of the folks here will do, that folks who are interested in JRuby will do, there are a lot of non-technical, non-development tasks that we could use help with. Taking a look at all of our open issues. Right now, I think we're in around 650 open issues on JRuby. I guarantee we don't have 650 actual bugs in that list. Many of these have probably been fixed. Many of them are no longer valid. They're about old versions of JRuby that aren't supported anymore. So going through our issues, looking for things that work, looking for issues that don't have enough information, that is a huge help for us. Of course, you can add to our wiki, update documentation, things you find out as you play with JRuby or when we have conversations about how stuff works. Get it into our documentation and help us out there. You can also just respond to questions. If you're using JRuby, if you're starting to play with it, get on our mailing list, monitor the JRuby accounts on Twitter, help other people out. Help them learn how JRuby works and get involved. Let's see, social media. Okay, yeah, and just get out there and talk to people. If you're using JRuby, tell people. We love to hear about it. We want people to know that JRuby is a solid option for them to deploy applications, and there's a lot of advantages to doing so. So now if you're a Ruby developer and you want to help out with JRuby, you can actually do that. A large and growing part of JRuby is just implemented in Ruby itself. So if there is a feature that's not working right, or a missing method from MRI that we didn't realize was there, maybe the tests were a little bit too light, you can write that in Ruby. We can throw it into our core of Ruby code, and it'll work just fine. So it's fine to just use Ruby to do it. Going through bugs and reports and issues and whatnot, and just taking whatever that bug is and reducing it down to a simple piece of Ruby code. The smaller the code, the more quickly we're going to find it and fix it. A lot of times people will just drop an application on us in the bug tracker. And we're like, you got to find something a little bit more localized for us to figure it out. As I mentioned, implementing new features in Ruby works. And like I say, we're not really concerned about the performance of the Ruby code. Usually it should run pretty well. Writing the code in Ruby is not an issue generally. If we have performance concerns, we can deal with that later on. Now, if you are a Java developer or you know Java and would like to work on some of the internals of JRuby, of course, we'd love to have your help there too. Most of the core classes, array and string and so on, are implemented largely in Java, partially for performance, partially for some of the tooling that we get out of the language. But it's very clean code. We've done a pretty good job of documenting things, making it look easy, making it simple to read through. We've gotten lots of compliments on how clean it is and how easy to follow it. We try to keep it nice and good. So this isn't the Java you might have seen from years ago. It's much cleaner and better than it has been in the past. And as I say, the core methods for the core classes, if you are interested in compiler technology or interpreters, we're always interested in having folks come in and help make our compiler and interpreters better. Here are some links for you to get involved. We have an IRC channel. We are on Gitter, but we try not to split our attentions too much. I try to monitor both, but either Gitter or IRC are great places to get in contact with the rest of the JRuby community. Of course, there is the JRuby mailing list, which is hosted same server as the CRuby mailing lists. And there's GitHub for us. Just come on. The JRuby organization has all of our different sub-projects, JRuby itself, of course, and a bunch of tooling and fun things for playing around with Java libraries. And I think that's about all I have. Finished a bit early. Good. So thank you very much. Hope you'll try out JRuby.
Thank you. Thank you very much. I really like that you mentioned the GraalVM.
Yeah.
And can I have a question?
Yeah, sure.
Okay, so truffle Ruby. I
Yes.
had to ask, sorry. So I don't know who knows, for a while there was alternative Ruby runtime. Basically, the development was going in a separate branch, but now Oracle Labs decided to fork the project.
Right, so the Truffle project, Truffle Ruby, is another JVM Ruby implementation with a very different approach, where we're trying to be more directly integrated with the Java language, just standard implementation. They're using a separate library called Truffle that does a lot of interesting optimizations, but it was also not really a good fit for the way our project works. So they're continuing on with a focus on performance and trying to get some C extensions to run directly. It's going to be a big challenge for them. They've got a ways to go, but also great project to check out.
Thanks. Thank you.
All right, thank you.